Welcome to lesson 1.7 on circles. What is a circle? Well, it is not Sir Cal. It's not Cal after he's been knighted Sir Cal. A circle is a set of all points in a plane at a given distance from a given point. The given distance is called the radius, and the given point is called the center, and you name a circle by its center. If two or more circles have the same radius, then they are congruent circles. And if two or more circles share the same center, they are concentric circles. Concentric circles. So concentric circles would look kind of like a wheel. They have the same center, but they're different size. A circle is circumscribed about a polygon if and only if it passes through each vertex of the polygon. And a circle is inscribed in a polygon if and only if it touches each side of the polygon at exactly one point. There's a picture of a circumscribed circle and an inscribed circle. Now to the arc. What is an arc? Well, it's not the boat that Noah built. In this case, an arc of a circle is or consists of 2 points on a circle and a continuous unbroken part of a circle between the 2 points, like you see there. There is arc AB, and you'd write it uppercase A, uppercase B, and little arc on top. The 2 points are called endpoints of the arc. Now, there's different types of arcs. There's a semicircle, and a semicircle is an arc of a circle whose endpoints are the endpoints of a diameter. And a minor arc is an arc of a circle that is less than a semicircle. And a major arc is an arc of a circle that's greater than a semicircle. Okay, now while an arc isn't the boat that Noah built, we can draw Noah's Ark here. If I just have a circle here, and let's go ahead and draw Noah's Ark. Do my best to, this is the center here, call that point P, and we'll call that A. So NA is a diameter, and then we have H. There is Noah's Ark. So we have a semicircle. So a semicircle would be like this right here. This yellow arc, it's half of a circle, and then a minor arc might be like arc NO or arc OA. A major arc would be maybe if you take that semicircle and continue it a little bit more. Let's say we go like this. So that purple, that AH is a minor arc, and then N to A to H is a major arc. This becomes a little bit of a naming. Well, naming of the arcs, we either use 2 letters or 3 letters. Which arc do you think we're going to use 2 letters for? A minor arc, major arc, or a semicircle? Well, a minor arc. Minor arc has the letters of the 2 endpoints on it, such as NO, or up above AB. For semicircles and major arcs, you need 3 points. To make it clear which arc you mean, the first and last letters of the endpoints, and the middle letter is another point on the arc, such as, let's do NO. OA. That would be a semicircle. What's another semicircle? NHA. What about a major arc? NOH, major arc. Or NAH. Wait, are NOH and NAH the same arc? They sure are. We don't need to say Noah's Ark. We can just say Na arc or no arc. So there we go. We can actually measure arcs too. Arcs have angle measures or degree measures, just as angles do. So you can say the measure of this arc is 40 degrees, or the measure of this arc is 50 degrees. And a full circle has an arc measure of 360 degrees. And a semicircle or half a circle has half of that, 180 degrees. The arc measure of a minor arc is the same as the measure of the central angle, which is the angle with its vertex at the center of the circle, sides passing through the endpoints of the arc. The measure of the major arc is the reflex measure of the central angle. So going back to Noah's Ark here. N, O, A, H. Let's say I have center point P. Let's say this is 80 degrees. What would be the measure of arc NO? Well, it would be 80 degrees. So you'd write it out here, 80 degrees. And that's the measure of that arc. It's the same as the central angle NPO. So it's the same as the measure of angle NPO. That's going to be the same. What about the measure of the major arc? The major arc NHO. What's the measure of this major arc? Well, we can see that if an entire circle is 360, then it would just be 360 minus 80. And that would be true. What's that, 280 degrees? And that's also the measure, the reflex measure of this angle, 280 degrees. And then you could write it out here if you want to indicate that's the measure of that arc. Okay. Let's go ahead and do some sketching. Sketch two circles that share a common radius. A common radius means they have the same radius. So let's go ahead and draw one circle. Here's a radius, and then another circle that has the same radius. It's kind of tricky, but you'd kind of draw a circle right about there. We'll call this point P and this point Q. And so circle P and circle Q have the same radius. Because they have the same radius, we can assume that they are congruent circles. Congruent circles. Now, sketch two circles that share a common chord and a common tangent. Can these circles have the same radius? Let's see. So, common chord and a common tangent. Let's go ahead and draw. Well, wait a minute. This looks just like what we draw, doesn't it? Yeah, we could probably draw that. Let's do that. Let's go ahead and it's pretty similar to what we have, but they need a common chord. Now, what's a chord again? Well, a chord is a segment that goes endpoint to endpoint, and it hits both points on that arc. So what if we were to take this picture up here and just draw a chord right here, and then add a tangent onto it? Yeah, look at that. So yes, these circles can have the same radius. Cool. All right. Closing question. Can two arcs have the same measure but different lengths? Turns out they can. Yes, they can. So here's an example. Let's go ahead and draw 2 concentric circles. That will probably be the best visual for why that is. So if you have 2 circles, they have the same center. And I'm going to try and draw that a little bit. Center is about right there. Okay, a little bit better. They have the same center, and let's go ahead and draw that angle there. Now remember, the measure of the arc is the measure of the central angle. So if this angle here is, let's say, 45 degrees, then the measure of this arc is 45 degrees, and the measure of this arc is 45 degrees. But it looks like very clearly they definitely do not have the same lengths. So yes, just because they have the same measure does not mean they have the same length, because they can have different radiuses, and that will change the length of the arc. Okay, well, that concludes lesson 1.7. And unfortunately, Sir Cal has still not been knighted Sir Cal. He is still Cal, but that's okay. And remember that without geometry, well, where's the point of it all? And hope you have a good rest of your day. We're going to go ahead and continue this in class. And there's a lot of vocabulary here, from circle, circumscribed, concentric, radius, inscribed, arc, semicircle, major arc, and arc, measure, central angle. So all these vocabulary words, take the time to become familiar with them, as they will come back again throughout this course. Have a good rest of your day.